Let's look at our third example here. Well, third word problem example. A tank is filled with water in the shape of an inverted cone 20 feet high. So here's my inverted cone. Here's 20 feet high. With a circular base on top whose radius is 5 feet. Water is running out of the bottom of the tank, so water is dripping out of here at a rate of 2 cubic feet per minute. How fast is the water level falling when the water is 8 feet deep? Alright, so I got some work to do here, okay? So I drew my picture of my cone here, got things labeled, okay? Now let's see what they're saying here. A tank is filled in the shape of an inverted cone 20 feet high with a circular base on top whose radius is 5 feet. Got that line taken care of. Look at your next line. Water is running out of the bottom of the tank at a constant rate. To me, that sounds like a derivative, right? A derivative with respect to t. But what is it? What is changing with respect to time here if water is running out the bottom of the tank at a constant rate of 2 cubic feet per minute? If water is running out of this tank, isn't that the change in the volume with respect to time? So that's going to be equal to what? 2 cubic feet per minute. I'm going to call it a negative since the volume's decreasing, okay? How fast is the water level falling? How fast? So that's another rate, right? How fast is the water level falling? So what is that? That's like this height right here. They're wanting to know how fast. What rate is that height changing? So that would be dH over dt. They want to know how fast is that falling or changing. So that's an unknown. When the water is 8 feet deep, so whenever h is equal to 8 feet. Remember, h is 8 feet. Remember, this is r. All right, so what's the volume of a circular cone like this? Volume will equal to 1/3 pi r squared times h. You're going to need to memorize that formula for the volume of a cone. 1/3 pi r squared times h. All right, now, there's my formula. It has v in it. It has h in it, right? And I need the derivative with respect to t. Well, let's see what happens if I try to take the derivative of both sides of this thing right now, okay? So I don't write this down right now. I'll tell you when to write it again. So if I take the derivative with respect to t of this thing, I have dv over dt. All this is constant, so I can pull that out in front, 1/3 pi. Then I need to take the derivative of this stuff using the product rule. So that'll give me first times derivative of second plus the second times the derivative of the first. All right, so dv over dt, I can put in -2. 1/3 pi is just 1/3 pi. I don't know what r is, but I could probably find it. I could put in a number right here, squared. dH over dt is unknown, so that stays dH over dt. Plus h is 8 here, times 2, and I can find that number for r, times, what was I supposed to put here? I was supposed to put what? dr over dt right there. That's what that should be, dr over dt. All right, so what happens whenever I try to put in a value for dr over dt? They never give me that, so that's dr over dt. And I have two unknowns here to solve for, which I cannot do. Cannot do that. So I can't work that problem like that. All right, that's what I told y'all. Do not write this down. So we're going to have to think of another way to deal with this. What was the problem I had? dH over dt and dr over dt were unknown. Now, I want to keep dH over dt because I'm going to have to solve for it. The dr over dt, I'm going to find a way to get rid of that. So what I'm going to do is I'm going to rewrite this r in terms of h somehow, to where h is my only variable. So let's see. What I'm going to do is I'm going to draw this portion, this triangle portion right here of my cone. So I'm going to draw that over there. This was 5 feet, we said. What is the height right here? 20 feet. And I'm thinking of water running out of this cone, okay? The water running out of the cone. So at some point you're going to have a radius right here, and you're going to have another height here, another radius and another height for that water level, right? Well, let's see. Right here I have a 90-degree angle, right here I have a 90-degree angle. So this angle is the same in this large triangle as it is in that small triangle, right? And both of these angles right here are shared by both triangles, right? So they're going to be the same. So these angles, this angle is the same as that angle is the same as that angle, so that will force this angle and that angle to be the same, so we have similar triangles. Who cares if we have similar triangles? Well, we do. Because we can say the ratio of corresponding sides are equal. What does that mean? That means radius over height of the small one, radius over height of the small triangle is equal to radius over height of the big triangle. Radius over height of the small triangle is equal to radius over height of the small triangle. Well, that's r over h is equal to 1 over 4 if I simplify. And if I multiply both sides by h, I'll get r is equal to 1/4 times h. R is equal to 1/4 times h. Now, what did we say earlier? We're going to sub in for r. So I'm going to put 1/3 pi, but instead of r squared here times h, I know that r is 1/4 h. So I'm going to do that. Well, let's clean this up before I take a derivative. So volume is 1/3 pi times, this will be what? 1/16 h squared times h. Or I could say volume is equal to 1/3 pi times 1/16 times h cubed. Now let's take the derivative with respect to t here. So we get dv over dt is equal to, all this is constant, right? 1/3 pi times 1/16 is all constant, so we pull that basically to the front. And then we take the derivative of this part with respect to t. What would that give us? 3h squared times dh over dt. Well, does 1/3 and 3 divide each other out? So we have dv over dt is equal to, I can call this pi over 16 times h squared times dh over dt. What is dv over dt? dv over dt is -2. Pi over 16 is just pi over 16. What's h at this instant? We're looking at the instant, h is 8 feet. So I'm going to put in 8, let's square it, times dh over dt is our unknown part. Alright, so we get -2 is equal to what? Pi over 16 times 64 times dh over dt. Need room here. All right, could I simplify this a little bit? What is the 16 divided by 16? 1. What's 64 divided by 16? A 4. So -2 is equal to 4 pi times dh over dt And let's go ahead and divide both sides by 4 pi. So what do we get? Negative 2 over 4 pi is equal to dH over dt, or negative 1 over 2 pi is equal to dH over dt. Now, did they want me to round or anything? Let me go back and look at my problem. No, it does not want me to round, so I'm going to leave it exact. What are my units going to be over here? Units of h over units of t. So this is negative 1 over 2 pi. What's the unit of h? H is the height. We're measuring the height in what here? Feet per, what's the unit of time we're looking at here? I don't know, I erased it, I think. Yeah, sure did. My unit of time was minute. There we go. So what is that? You think about the cone that we had. That's how fast this height was changing whenever the water was 8 feet. Whenever the height of the water was at 8 feet, how fast that water level was changing at that instant.